Storms, in all their magnificent fury, are a testament to the raw power of nature. But behind the spectacle of lightning and the roar of thunder lies a fascinating scientific process. The birth of a storm is a delicate dance of atmospheric ingredients, beginning with the seemingly innocuous warmth of the ocean's surface. The sun's radiant energy heats the ocean water, causing it to evaporate and transform into warm, moist air. This buoyant air rises, embarking on an upward journey into the cooler reaches of the atmosphere. As it ascends, the air cools and condenses, forming the familiar sight of billowing clouds. These clouds are the building blocks of a storm, but they are only the beginning of the story. For a true storm to form, we need a crucial ingredient: atmospheric instability. Imagine the atmosphere as a layered cake. If the lower layers are warmer and more humid than the upper layers, the atmosphere is unstable. This instability creates an environment where the warm, moist air can continue its rapid ascent, much like a hot air balloon released into the sky. As the warm air rises, it creates a void, drawing in surrounding air. This influx of air from different directions is known as converging winds. These converging winds collide, further fueling the upward surge of warm, moist air, creating a powerful updraft, the backbone of our developing storm. Within this swirling vortex of rising air, tiny water droplets collide and coalesce, growing larger and heavier. Eventually, they become too heavy to remain suspended and begin to fall as rain. If the updraft is particularly strong, it can keep these water droplets aloft, allowing them to grow even larger, eventually forming hail. The dramatic display of lightning and the accompanying rumble of thunder are born from the friction within the storm clouds. As ice crystals and hailstones collide within the turbulent updraft, they create an electrical charge. This charge builds up, creating a difference in electrical potential between the cloud and the ground, eventually culminating in a dramatic discharge of energy, the flash of lightning. The rapid heating and expansion of the air along the lightning's path creates a shockwave that we perceive as thunder. The type of storm that emerges from this complex interplay of atmospheric forces depends on a variety of factors, including the intensity of the updraft, the amount of moisture in the air, and the prevailing wind patterns. From localized thunderstorms and destructive tornadoes to sprawling hurricanes and freezing blizzards, each type of storm possesses its own unique characteristics and potential for devastation. Eventually, as the supply of warm, moist air diminishes and the updraft weakens, the storm begins to dissipate. The rain tapers off, the winds subside, and the clouds gradually disperse, leaving behind a calmer, often clearer, atmosphere. The storm has run its course, leaving a reminder of the immense power and complexity of the natural world.
Thanks for your watching. Please hit the subscribe button and ring the bell for more interesting videos next time.